So number 9 from 8.3 says a researcher estimates that the average height of the buildings of 30 or more stories in a large city is at least 700 feet. A random sample of 10 buildings is selected and the heights in feet are shown. At alpha is equal to 0.025, is there enough evidence to reject the claim? Our first step in here is we have to determine the claim. So our claim, remember, we always have H0 and H1. Some classes might use H sub A, same thing. And remember, H0 is always equal to, and this H1, we're not sure yet, but we know we have mu here and mu here. And now to determine our mu, let's look at the population sample. So a researcher estimates that the average height of the buildings, blah, 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 is at least 700 feet. So mu is equal to 700. So here's our 700 here. And they want to know, it says, is there enough evidence to reject the claim? So our claim here is that the buildings are at least 700 feet. So remember, at least mu is greater than or equal to, so at the very least it can be 700. But when you're doing these, you can't have greater than or equal to or less than or equal to. So therefore, when you see greater than or equal to, you're going to change it to less than. If it's less than or equal to, you're going to change it to greater than. So here, since we have greater than or equal to, we're going to change it to less than. So now to determine our claim, is it the claim that it's equal to 700 or the other one? And at least 700, so H1 is our claim. Step 2, we do that part, determine H0 and H1. Now we have to draw the t-distribution and shade in the proper number of tails. So remember the t-distribution, let's draw that. And remember the number of tails is determined by this symbol here. It points to the left, so we have a left tail. We have a left tail test here. So our value is going to go here, our critical value. And now that we know that, let's write down the other information that we are given. So it says a researcher estimates that the average height of the buildings of 30 or more stories in a large city is at least 700 feet. So we got 700 as mu. This 30 you might think is n, but 30 stories, is that a sample size? We're looking at the height of the buildings, not how many stories. So this is just trying to mess you up. You don't need the 30 or more stories. A random sample of 10 buildings. A random sample of 10, that means n is 10. And the heights in feet are shown. At alpha is equal to 0.025. Is there enough evidence to reject the claim? So that's all the information that we're given. So we have to calculate the rest of it through the values they give us. So we need x bar, we need s, we need our degree of freedom, and we need our critical value and our t. So we can compute degrees of freedom easily. It's n minus 1, so degree of freedom is 9. Now let's go to our t-distribution and calculate or find our critical value. So remember, when you're looking at this t-distribution, we want to look at the proper number of tails. So we're looking at one tail, and our alpha is 0.025, and our degree of freedom is 9. And where they meet is 2.262. So that's our critical value. 2.262, and because it's a left-tailed test here, it's on the left side, this would be 0, it's going to be negative. So our critical value is negative. So let's put that in there, negative 2.262. Let's move that over a little bit. Negative 2.262. Okay, the next step is to compute the test point. So don't confuse your critical value and your test point. Your critical value is kind of what you're gauging your calculation off of. So you look up your critical value and you compute t. And remember, t is computed using x bar minus mu times the square root of n over s. Now we don't have x bar yet, or s. So we have to calculate that in our calculator here. What you want to do is you go to Stat and Edit, and you want to put in all your values here. I already put mine in. They're already in here. Then you want to go to, let's do Stat, Calc tab, first bar stats, and hit Enter. Here is our X bar at the top, and our sample standard deviation. Remember sample because you can't determine a population standard deviation from a sample. So we have our X bar is 606.5, and our sample standard deviation is 109.08. So let's put those in here. X bar is 606.5, and S is 109.08, I believe. Let's double check that. Yes. Okay. So now that we have that done, let's calculate T. So we have X bar is 606.5 minus 700 times the square root of n, which is 10, over S, which is 109.08. Let's plug that in our calculator here. So we have, let's clear this so you don't get confused. Okay, so we have, make sure you use your parentheses around those subtractions right here, around your subtraction. Very important. Otherwise, your calculator will do 700 times the square root of 10 first. You don't want that. So we put 606.5 minus 700, close parenthesis, and times the square root of 10, and then times, or divided by 109.08. And that will give us our t, our test point of negative 2.71. So t is negative 2.71. I'm going to erase all that. Negative 2.71. Put that over here. So now we have our test point. Almost done. Now, t is negative 2.71, and negative 2.71 is smaller. Negative 2.71 is right here. It's in the shaded area, therefore we reject. Reject H0. And they want to know, is there enough evidence to reject the claim? So we say reject H0. There is enough evidence to support the claim, so therefore we are not rejecting the claim. We are rejecting H0, but we're not rejecting H1 here. So there is enough evidence to support the claim. Now, some professors want you to keep going and finish it according to what they want you to say. according to what the question was. So you would say there is enough evidence to support the claim that the average height of the buildings of 30 or more stories in a large city is at least 700 feet.